And happy Tuesday. It is the 5th of November here in New Zealand, where our Electron rocket is ready for its next mission to space. We are counting down to our 11:54 p.m. local time liftoff for today's launch for a confidential commercial customer. Now, launch operations have been going smoothly so far, and the weather is expected to remain clear all the way through to T0. Electron is looking good, and our operators are ready to make their way through the final few milestones in the countdown to liftoff. My name is Mähia Baker, and I am joining you from our Mission Control Centre in Auckland, New Zealand. Now, today's mission will be the 54th time Electron lifts off the pad and heads to space, carrying its 198th payload on this dedicated mission. A dedicated launch service means the satellite operators who fly with Electron get to choose and change their launch date, pick which of our launch sites to fly from, and in some cases launch on incredibly short notice. And that will be the case for today's mission, which we are launching to orbit in less than 10 weeks since the launch contract was signed, making this one of the fastest Contractor launch turnarounds since Electron has been flying. We're back on Pad B for today's launch, our second of two launch pads at our private orbital launch site on the east coast of New Zealand. Electron will fly today with its payload on a southern trajectory across and over Antarctica on its way to low Earth orbit. Our next check-in with Mission Control will be in just a few minutes, when our launch director will begin their status check-in with the Mission Control operators, called the Go-No-Go poll. But since we've got some time until the 9 Rutherford engines at the bottom of Electron ignite for liftoff, let's enjoy some beautiful footage of a different rocket engine. Our medium-lift launch vehicle Neutron will be powered by the Archimedes engine that we are building at our Engine Development Center in California, and hot firing at our propulsion test complex at NASA's Stennis Space Center in Mississippi. Now, we've been burning hot this summer with Archimedes hot fires, putting our new liquid oxygen and methane oxidizer-rich closed cycle engine through hundreds of tests and various operating stages. So let's check out some of that footage. An engine test and development campaign is an iterative process that means lots of tweaks and pushing engines to their limits. And Archimedes is well into this process now, and we continue to be impressed with its performance. You can look forward to seeing a lot more blue flame as that campaign continues. Now, the propulsion team has designed Archimedes as a next-generation reusable rocket engine. Now, Neutron will fly with a configuration of 9 of these staged combustion liquid engines on its first stage, using Archimedes to launch and land the reusable first stage of the rocket with a combined liftoff capability of 1,485,000 pounds of thrust. Now, Neutron's second stage will fly with a single vacuum-optimised Archimedes, capable of up to 200,000 pounds of vacuum thrust. Now, taking a newly designed staged combustion liquid rocket engine through to hot fires in its flight configuration in just a few short years is a really impressive effort by the team. Because building your first engine is hard, but building the next 10 and the next 50 is even harder. And that's why our production teams have worked in parallel to have the manufacturing and assembly lines up and running for Archimedes. And just recently, we shipped another Archimedes out the door that's already arrived at Stennis for testing, bringing us closer to Neutron's first launch next year. All right, time to get back to our workhorse Electron rocket, the 54th of its kind since our first launch in 2017. And we are coming up shortly to the go, no-go sequence run by our launch director in mission control, Paula Torres Serralonga. Now, we have operators stationed at the Mission Control Centre, you can see on your screen here, and at our Range Control Centre located at the launch site. So at T-minus 12 minutes, our launch director will begin the poll to check that all stations are ready to proceed with those final few minutes of the countdown. And that is coming up now in just a few seconds.
To all stations LD in Mission Corps, proceeding with go-no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Vcon.
Vcons go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
And LDSUP.
LDSUP is go.
Go-no-go sequence complete. We are T-minus 11 minutes 25 seconds and counting. We are go for terminal count auto sequence starting at T-minus 10 minutes. From this time, the 3-hole procedure is in effect.
All right, as you have heard, Mission Control has given the all clear to move ahead with today's final launch preparations. So the liftoff time has been set for 11:54 p.m. local time, which is also 10:54 UTC. We have a 2-hour launch opportunity today if that T0 time needs to shift for any reason. Otherwise, in just under 11 minutes from now, Electron will be off and on its way to low Earth orbit once again for its 12th mission of the year. Now, missions launched in 2024 so far include 2 launches within 11 days for the same NASA climate science mission, the deployment of a rendezvous satellite designed to clean up space junk, a rideshare launch that acted more like a dedicated launch by deploying 2 different customer satellites to completely separate orbits and altitudes on the same launch, and missions either starting or replenishing commercial constellations of satellites that provide Earth imagery and IoT connectivity.
GCLD mission card.
LDGC.
GC proceed with sequence 57 by terminal checks.
Understood, sequence 57 in work. Stage 1 ignited pressures verified, hydraulic pressures verified. LDGC on mission.
Speaking of satellites that do cool things, our space systems team have recently completed our latest spacecraft ready for its next in-space manufacturing mission and return to Earth. W2 is our program name for our Pioneer spacecraft built for Varda Space Industries, a company focused on in-space processing and hypersonic Earth re-entry logistics. Now, our next Pioneer spacecraft comes off of the back of our first spacecraft launched last year that helped to return Varda's re-entry capsule back to Earth. And we'll be providing the same support as that first mission, using our spacecraft to provide power, communications, propulsion, and attitude control throughout the manufacturing phase on orbit. Varda recently received approval from the Australian Space Agency for multiple vehicle re-entries into the Kaniba test range at Southern Launch in South Australia, which will enable Australia's very first commercial space re-entry, and we can't wait to be part of it. Now, once again, that spacecraft includes many of our own built components like our star trackers, reaction wheels, solar panels, flight software, radios, and carbon composite structures. And this one is just the latest in a lineup of exciting spacecraft that we're building right now, or which we have already completed, like 2 spacecraft for a science mission to Mars called Escapade, 2 completely different constellations of spacecraft, one for commercial communications, one for national security, and other individual technology test missions that range from radio connectivity in space to cryogenic fuel storage on orbit. Rocket Lab might be our name, but rockets were just the start, and we are much more than just a launch company today. So if the idea of working at an end-to-end space company covering launch, satellites, and everything in between gets you excited, then there is a place for you at Rocket Lab. And we've got open roles in our Electron, Neutron, and space systems teams across several states that could be right for you. Check out what it takes that makes our team the best in the world.
If you walk into any of Rocket Lab's facilities, the first thing you'll read is "We go to space to improve life on Earth." And that's really the foundation of the entire mission of Rocket Lab. So the way to think about Rocket Lab is we're not just a launch company, not just a spacecraft company, we are an end-to-end space company. And I think what sets Rocket Lab apart is you actually get to build hardware that goes to space. And not just go to space, but go to Mars, go to the moon. You're never a little gear in a giant machine. You get given huge responsibilities within the company. If you come to work at Rocket Lab, you can expect to build beautiful things that work beautifully. Don't expect 9 to 5, but do expect to have an actual meaningful impact on the world.
A check-in on the clock, and we are now at 4 minutes, 44 seconds and counting to launch with Electron. Now, in just a few moments, that countdown will be taken over by the rocket's onboard flight computer from T-minus 2 minutes. Checks are completed autonomously by Electron as it prepares for liftoff, though it will continue to receive liquid oxygen into its propellant tanks up until about T-minus 1 minute and 30 seconds. We'll know that has been completed when we hear a call out from the mission control operator that the lock system is in circulation. The next event will be confirmation that the rocket's first and second stages are fully pressurized for launch, which happens within the final 60 seconds to liftoff. And then it's over to the 10-second countdown by the launch director, with Electron's engines set to ignite at T-minus 2 seconds before liftoff. And all of that is coming up next, so we are going to bring up the mission control audio channels now and listen in.
From now, there should be no red flags on your critical LCCs. Beacon LD in mission court.
LD beacon.
Beacon, lock the auto sequence and confirm.
Auto sequence is locked.
Copy and confirm all expected primary flight computer outputs are green.
Confirmed.
We are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
The vehicle is fully on internal power. AFTS is green and enabled for flight.
LOX load is complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purge enabled.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Onward and upward for Electron's latest launch. The rocket has now reached speeds of more than 500 kilometers an hour as it approaches its first event, a milestone called Max Q. And this is when the rocket experiences the maximum amount of aerodynamic pressure, also known as the point in the flight when the structural load against Electron is at its peak. It's the guidance, navigation and control operator in mission control who will call out Electron's approach to Max Q and when it has cleared it.
Cleared Max Q.
There we have it. Confirmation Electron has passed through Max Q. We are now past 1900 kilometers in altitude, traveling per kilometer per hour and past 18 kilometers in altitude. Now, next up are the three key events coming up next. The main engine cutoff called MECO, stage separation, and then stage 2 engine ignition. MECO is when all 9 Rutherford engines shut down simultaneously to prepare for the next phase in flight. And then after those engines shut down, Electron's first and second stages will separate. Now, stage 1 will return back to Earth, while stage 2 heads in the opposite direction to continue onto orbit. Then finally, the vacuum-optimized Rutherford engine on Electron's second stage will ignite to carry on with the mission. And those 3 events all take place in quick succession over just a few seconds. So let's listen in for those calls now.
"15 seconds till staging."
Entered burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
As you've just heard, Electron has just had a successful MECO, stage separation and second stage ignition confirmed. Telemetry data shows that Electron is moving now at more than 7,800 kilometers an hour, now almost past the 100 kilometer altitude above Earth. It is T plus 3 minutes and 15 seconds into the mission, and coming up next is fairing jettison. And that is when Electron's nose cone will split down the middle and fall away from the rocket in preparation for payload deployment later in the journey.
Stage 2 propulsion is nominal.
Fairing jettison confirmed.
We heard it there from Mission Control. That fairing has now separated and jettisoned. And we are 4 minutes, 22 seconds into the mission and well on our way to orbit. We have another couple of minutes to go with this second stage engine burn. That's the nozzle you can see on your screen that is attached to the single Rutherford engine that is powering that second stage. Now, this engine here has a total of 5,800 pounds of force in the vacuum conditions of space, with a specific impulse of 343 seconds, which is the measure of how efficiently the engine is generating thrust, that force that moves the second stage through space. Now, like the 9 Rutherford engines used on the first stage, this second stage Rutherford engine also uses batteries to power its propellant pumps. And shortly we'll be approaching a launch milestone related to the batteries that is called the battery hot swap. And that's coming up shortly at around T plus 6.5 minutes.
Guidance is nominal, 200 seconds remaining.
Using batteries to power the Rutherfords is one of the key pieces of its design that sets it apart from other rocket engines. Our world's first 3D printed electric pump-fed engine uses battery packs to drive the electric motor for the fuel and oxidizer pumps. And since the amount of time that the second stage engine needs to burn is longer than the capacity of its first battery packs, the engine will switch to a second set of batteries to keep that engine running to full duration. And this is called the battery hot swap. We should see it take place on our screen when we see the first set of batteries eject and fall away from the rocket, indicating a smooth transfer of battery power for that engine. So let's watch out for that now.
Throttling down.
Battery jettison confirmed.
Hot swap successful.
There we go. That is battery hot swap confirmed visually and from what we just heard from Mission Control just now. The mission is continuing nominally along its trajectory, now past 211 kilometers in altitude and getting close to its required orbital speed of around 27,000 kilometers an hour.
AFTS has saved.
The team in Mission Control are closely monitoring this Stage 2 burn as we get closer to SECO, or Second Engine Cutoff, now under a minute to go until that next milestone. Electron is otherwise continuing nominally and the payload on board remains healthy, and we are now at more than 217 kilometres above Earth, cruising along at more than 19,000 kilometres an hour. It is now T plus 8 minutes, 2 seconds into the mission. The second stage engine continues to burn, but very soon we will be coming up to that second engine cutoff. So that Rutherford engine will be throttled down just before cutoff to help maintain a steady state for the kick stage and its payload during the separation event. A clean stop of the engine will show the nozzle changing from red, hot to cold on your screen, and we can expect to hear a call out that SECO is confirmed from Mission Control at the same time. So let's listen in.
Guidance is in terminal, 20 seconds remaining.
SECO confirmed.
Stage 3 separation confirmed. Nominal transfer.
Great news there from Mission Control. The second stage engine has shut down and the kick stage with the mission's payload has now separated. So the kick stage has arrived in an elliptical orbit around the Earth where it will coast for about 45 minutes before its engine ignites to circularize its path. And then soon after that circularization burn is complete, we will be ready for payload deployment from the kick stage. Now, occasionally our customer requests some commercial sensitivity, and this is one of those times, so we won't be showing the coast phase or payload deployment sequence live on this webcast, but we will share updates confirming payload deployment across our social media channels and everywhere else that you find your Rocket Lab news. Now, while there is only a few months left in the year, we are far from finished launching, so you won't have to wait long for the next Electron liftoff. Keep a close watch on upcoming announcements for when and where those launches will take place. But until then, thank you for joining us for today's launch. This is Rocket Lab Mission Control, signing off.